think we can finish it. If not, I'll just cut the video. Okay, so this one I wanted to show you because I saw a couple of problems on your homework where you had what's called a composite figure. Composite figure is when you combine two figures together, create this other fun figure. So you should have noticed this on your quiz from today and also last time, where you had to find the surface area or volume of this house looking thing. So right now we have one that looks like a fun ice cream cone. Yay. I want some ice cream now. No, Copper, you can't have any. So what you want to do is obviously find the surface area and volume of both and add them together. But it's a little tricky when dealing with surface area. And you will notice that on that 11-2 quiz. So the surface area of a composite figure is the outer surface, okay? So what that means is, in this example, if I were to actually give you this like ice cream cone style figure, you would not be able to physically touch this surface because it's not on the outside, and surface is only like something on the outside that you can touch. So that is not included in your surface area. What does that mean? That means that I'm calculating the lateral area of this cone here and not the base, okay? And then for the top part, I have this what's called a hemisphere. Hemisphere is half of a sphere, okay? So you do the formula like normal for a sphere and divide it by 2. And that's the hemisphere formula for surface area and volume, okay? And then for this cone, we're going to need to do lateral area only, right? Because if we do surface area, that includes the base, and we don't want to include the base, okay? I'm going to make a little note. I'm going to put it in red because it's bad. So don't include area of the base. Okay. All right, so let's do this one quickly. We're going to do both surface area and volume of this figure. So total surface area, I'm going to break it down into 2 parts, the hemisphere and the cone. So the hemisphere part, I'm going to be doing 4 pi r squared divided by 2. Well, what does that simplify to? 2 pi r squared. Boom. So all you got to do is plug in your radius. Since the diameter is 12, the radius is going to be 6. So the surface area is 2 pi times 6 squared. So that's 36 pi and then times 2. So my surface area of the hemisphere is 72 pi. And then we want to combine that with the surface area of the cone. But remember, it's actually not total surface area. It's just the lateral area. Okay? This was surface area, lateral area. Okay, now we don't have to divide the cone by 2 or anything, right? Because that's actually a full cone. Okay, so you just go back to your 11-2 notes, right? Yeah, 11-2 notes for lateral area of a cone, but I'll remind you, it is pi r L. Remember that L stands for the slant height. Okay, and so that's what I gave you right up here. It's 10. So pi times 6 times 10. Coolio, that's 60 pi. All right, so the total surface area of the composite figure is 72 pi plus 60 pi. Excuse me. Which is going to be 132 pi. Did I give you units? No. So whatever the units were, units squared. Okay, not too bad, right? And then now let's find total volume of the figure. So volume of the hemisphere is going to be 4 pi r cubed over 3, but then this is where it gets a little tricky. Divide that by 2. Guys, when you divide a fraction by a number, you're really just dividing the numerator by that number. So 4 pi r cubed over 3 divided by 2 is going to only be 2 pi r cubed over 3. You see how I just took that 4 and I cut it in half? Okay, so if you wanted to find this first entire volume and then cut it in half at the end, by all means do that, okay? Whatever floats your boat. All right, so the radius is still 6, but now, be careful here, it is not 6 squared, it is 6 cubed. Okay, so 6 times 6 times 6, that is going to be 216. And then I like to multiply that by 2 first. And you get 432 pi over 3. Don't forget the dividing by 3 for a sphere. And that's 144 pi for the hemisphere. Okay, volume. And now we do the cone volume. Okay, and if you go back and look at that formula, it is pi r squared times the height divided by 3. This one's going to be kind of gross. Okay, so if you go back to your picture, guess what I did not give you here? That's right, the height. And how do we find the height of a cone if we're not given it? You guessed it, Pythagorean theorem. Our favorite thing ever. So I'm just going to do that in this space right here. We have a radius of 6, a slant height of 10. Oh, actually it looks like this is going to be quite nice because that is a Pythagorean triple. To find that height right there. That's an 8. Okay, if you're like Miss Copy, where did you get 8? That's crazy. 6 squared plus h squared equals 10 squared. And then you solve using your magic skills. Magical skills. 100 minus 36 is 64. Square root of 64 is 8. Right? Okay. So the height is 8. Let's go back to our formula down here. Volume is pi times the radius is 6 squared times the height, which is 8, divided by 3. 6 squared is 36. And 36 times 8 is 288 pi over 3, which is 96 pi. So our total area, total volume of the composite figure is 144 for the hemisphere plus 96 pi for the cone, and my total is 240 pi units cubed. Woohoo! Wasn't it so much fun? Okay, so just things to keep in mind when you're doing composite figures, or figures that are just kind of combined together, is that if you have something like maybe a cylinder, like so, with a hemisphere, a hemisphere on the top, so it'll look kind of like this. Remember, you do not want to include this part here. So you would be calculating the surface area of the hemisphere. Then, for this cylinder, you'd be doing the lateral area plus one of the bases, right? See, normally you would do LA plus 2B. Well, no, you only want to do 1B because I don't want to include the base in the middle, but I do want to include this base on the bottom, right? And that's where a lot of you guys went wrong on that quiz from before, where you had this like house looking thing like that, right? So a lot of you went ahead and calculated just surface area of both the pyramid and the cube, but you only went lateral area of the pyramid, not the surface area. And then you also only want lateral area of the cube plus the area of that base, because you do want to include the base, but only one of them, not two. If you have need some help with that, just come see me in tutorials. Thursday, Friday, I should be in there during the hour lunch that we have this week. Okie dokie. Okay, fun times. good luck on your homework. It's one part, not too bad. And we'll have a quiz next class. So Friday for Red Day and Monday for Gray Day. Yay, math! Bye now. Bye. Where's the